All right, 4.4, real zeros of polynomial functions, okay? So our goals here are to understand the factor theorem, to factor higher degree polynomials, to analyze polynomials having multiple zeros, solve higher degree polynomial equations, and to understand the rational zero test. Real zeros of polynomial functions. All right, so our polynomial factor theorem. So for the polynomial factor theorem, it's saying, given the graph of a polynomial, exhibit A, f of x, you're going to find the factors. Your factors are the x values where y equals 0. Does that make sense? Your factors come from the x values where y equals 0. So notice here, the x-intercepts, exactly. So notice here, we're at -7, 2, and 11, right? So therefore, my factors are going to be the opposite of them. So if I'm at -7, then my factor is x plus 7. If I'm at +2, then my factor is -2. If I'm at 11, then my factor is -11. Yes? Are we okay with that? So you identify the x-intercepts, and their opposites are the factors. Okay? So here are my factors. After I have my factors, I then am going to multiply them together to find my polynomial in standard form. So this is in factored form. And this is in standard. How do we feel? Terrible? Doable? Okay, so do we understand identifying our x-intercepts? Yeah, looking at the graph, we're across the x-axis. Step 2 is to write your x-intercepts as factors. So you're saying, what gave you the answer of -7? Well, I got -7 because I had x plus 7 equal to 0. Okay, what gave you the answer of 2? Well, I got 2 because I had x minus 2 equal 0. What gave you the answer of 11? Because I had x minus 11 equals 0. So then I write my factors. Step 3 is you're going to multiply your factors. So multiple distribution is going to take place. I'm going to multiply my factors to find the standard form of the polynomial. How about now? Yeah? No? I'm going to say we got it. Okay.
Something I actually did.
Okay, good.
Yeah.
Yay. Are you ready to try? All right, so here's our graph. So we're given the graph and we're going to write it in factored form. We're just going to make sure we're okay writing it in factored form. All right, so first step is to identify your x-intercepts. Where are my x-intercepts? -1, +1, and 2. Okay, check. Step 2 is to write their factors. So the factor at -1, where did -1 come from as a solution? It had to come from x plus 1. Does that make sense? Where did +1 come from? X minus 1. And where did +2 come from? X minus 2. So those are my factors. And that's all I want you to do right now. I forgot to put my commas. So we identified our x-intercepts. We listed out our factors. Identified the x-intercepts, listed out our factors. We have to be able to do this to keep going. Good? Anyone's like, never. Okay, cool. All right. So this is when you're given a graph. Now it's going to change when you're not given a graph. Okay? But when you're given a graph, it's easy. Correct? Everything's easier when you can just look at it. Now you have to calculate. But it's okay to calculate. The what? Nope, you don't have to even do that. It's even easier. Okay? So it tells us our zeros. So these are our x-intercepts. So they've already did the work for us. They are telling us our x-intercept. So step 1 is done. Does that make sense? So the math to find the x-intercept is completely done already. What's the second step? To write them as a factor, okay? This is where it gets just a little bit weird on finding the factor for your 1/2. When you have a fraction, it's written a little differently, okay? So 1/2 actually is written as a factor of 2x minus 1. Okay, why is it written as 2x minus 1? Because this would, if I set this equal to 0, that's what's going to make it a half. Does that make sense? So the factor for this is 2x minus 1. This is a pretty easy factor. 4, what's the factor for 4? X minus 4. Does that make sense? We're good. Okay, it asks for a complete factorization. And when it asks for a complete factorization, what that means is that it wants you to also take into account your A. So for this problem, what is our A? 7. So when we write out our factors, we would have to include 7, parenthesis, 2x minus 1 times x minus 4. And that's our complete factorization. If you have an A value other than 1, it's part of your complete factorization. Does that make sense? Technically, 1 is there at all times, right? He's just cast for the friendly 1. Okay, for this one, for example, I could have factored out 7 and then did the math myself, but the math was already done for you. If I factored out 7, this would have became a 1. This would have became a 9, and this would have became a 2. Do we get that? So I could factor out 7, and that's why it says complete factorization. Because 7 is a GCF, a greatest common factor. All right. Without a graph, how do you feel? Just given the x-intercepts. Yeah? We'll take the silence and head nods. All right. Do you think it's going to be any different now that we have a cube function? You hope not. Good job. It's not. Okay. It's not going to be any different with a cube function. You're still going to go through the same steps. You're going to identify your zeros, your x-intercepts. Did they give them to me? Yes, they did. They gave me my intercepts. Next, you're going to write them as a factor. What is the factor of -2? X plus 2. Factor of +1. Factor of +2. -2. Okay? It says complete factorization. So step 3 is saying, is your A value anything greater than 1? Or not even just greater than 1. Greater than 1. Is your A not equal to 1? Is your A not equal to 1? The answer is yes, it is. So therefore, you have another factor. And what's your other factor? 5. A equals 5. So my full factor of this would be f of x equals 5 times x plus 2 times x minus 1 times x minus 2. And I can double check because if I look here, can I divide each one of these terms by 5? Yes, I can. All right. Are you still okay without a graph? Yeah. Okay. So double checking, back to the graph. Now we have another graph. When I look at this graph, what are my factors? -1 and 2, right? We all see that? Now, what makes this one different? Did I put the same graph twice? I did. Dadgummit, Gina. Thought I gave you all a different graph. Is that at a half? That's at a quarter, whatever. All right, I thought I put a different graph. Joke's on you. But here, when we're writing out the factor, we're gonna write out what the full factor is, and that means that we have to take into the account that our a doesn't equal what? A does not equal 1. So we're gonna write it out without going through the whole thing. So f of x equals, what is our a value? Your a is -1/2, and then you're gonna write your x-intercepts. What is the first one as a factor? +1. What's the second one as a factor? And then the last one as a factor. So that is your fully factored. Okay, so right now we're being given our a. What if we're not given our a? What do you think we're gonna have to do? Solve. Oh my gosh, you're right. Okay. So speak now. Are you okay given the a, given the graph, or the a, given the zeros? Yes? Okay. All right. Now we're here. It says the polynomial f of x equals -2x cubed minus 6x squared plus 6x plus 6 has a 0 of 1. Express f of x in complete factored form. Oh no, they only gave me 1 0, and this is a degree of 3. What do I do? Glad you asked. Okay. When this happens, that means you're going to use synthetic division to find your other zeros. Okay. You're going to use a combination of synthetic division, factoring, and or quadratic to find it. So step 1, we're going to use synthetic. Okay. And you're going to use synthetic knowing that your 0 is what? 1. So 1 is going to be in my box. I'm going to write out my coefficients. So we have -2, -6, +2, and 6. I'm going to bring down -2. And again, we diagonally multiply, vertically add. Diagonally multiply, vertically add. So we have 1 times -2 is -2, -6 and -2 make 1 and -1 make 2 minus 8 is, and 1 times -6 is -6. And we got 0 because we should have gotten 0, right? Makes sense why we got 0. So we're at 0, and now we're here at -2, -8, -6. So that means that I'm working with -2x squared minus 8x minus 6. So now we're going to either use factoring or quadratic. So now you're going to either factor or use the quadratic formula. So if I want to factor this, the first thing I'm going to do is I'm going to factor out the GCF. What is the GCF between -2x squared minus 8x minus 6? 2. I can divide, to be more specific, I can divide everything by a -2. So factoring out with GCF, and I'm left with x squared plus 4x plus 3. So continuing my factoring, it's going to ask me, I'm asking what multiplies to give me 3, but adds to give me 4. What are my factors? So my factors would be x plus 3 and x plus 1. And our last step is now we're going to write it in full factored form. So full factored. When you're fully factored, that means you're going to start off with your a value. What's our a? Our a was -2. And then we're going to write our factors, our zeros. The 0 they gave us was 1, right? So our first factor would be x minus 1. And then what were the factors that we got from synthetic? X plus 1 and x plus 3. So here is my fully factored. My a, and then my zeros. All right, yes.
So on step 2, or the multiply to get 3 and add plus 4. If the liar, you don't put it as minus 3 and minus 1.
You put that when you're solving, like when you're telling me what the zero is. So like if I ask you what's your zero, you would then say -1, -3. But in factor, it is just in factored form. Okay. And that's why right here, when we took our 0 and wrote it as a factor, we wrote it as x minus 1. Your zeros and factors are opposites of each other, not from the solution. All right. Any questions left? Good. All right, let's do a word problem. An insect population P in thousands per acre, X days past May 31st is approximately P of X equals 2x cubed minus 18x squared plus 46x, where X is between 0 and 6. Determine the dates when the insect population equal 30,000 per acre. Okay. So our equation, it wants us to find out when does 2x cubed minus 18x squared plus 46x equals 30. All right. So before we get started, we have to make sure that it's equal to 0. So we're going to set this equal to 0. What do I need to do to make this equal 0? Not divide, just subtract 30. So now I'm working with 2x cubed minus 18x squared plus 46x minus 30 equals 0. Okay. After I do that, I then want to start factoring. Whew, I'm getting old. Okay. If I was to start factoring, so step 2 is where we're going to factor. I can factor out a GCF. What is the GCF that I can divide all of these by? 2, right? So we're left with 2, and we have now x cubed minus 9x squared plus, my cube got weird, plus 23x minus 30. Okay. Yes. Oh, 15. Thank you, Juan. Shh, you guys. All right, minus 15. All right, so now I'm looking, can I factor any more than that? I don't think so. Can't factor by grouping. Can't take anything else out. So I'm down to x cubed minus 9x squared plus 23x minus 15. After this problem, we're going to learn how to estimate our values that will be factored. But for this problem, we're then going to go and look at our calculator to see where our x-intercepts are. So I'm going to graph this and I'll locate my x-intercepts. Handy dandy calculator. All right, so I'm going to go to y equals, and I'm putting in x to the third minus 9x squared. Oops. Toodles. I said toodles. What'd you say, Juan? You just press the caret button. Are we good? Now we're gonna go look at our graph. Does your graph look like that? It does. Good. All right. We need to find our x-intercepts. So we can try with the table first. So if I go to the table by hitting second graph, I can look and see where my zeros are. Sometimes that's faster and helpful. Can I see where my zeros are? I see 1 0. I see 3 0. And I see 5 0. How about you? Huh? You see 1, 3, and 5 as your zeros? Okay, so that's option 1. The other option is from the graph. You can find your zeros by using second trace and see where it says 0. I'm going to press 2 for 0. Now you want to be able to see your little spider. So make sure you see your spider. And just like we read a book, we read our graph from left to right. So it says left bound. It just means that you need to be above or below the x-axis, depending where you are. So left bound right now means I'm going to be below the x-axis. And then I'm going to go right bound, make sure I'm above the x-axis. And it's going to tell me the same thing. You have a 0 at 1. Okay, I'm going to repeat the same steps. Second trace, press 2. This time I'm going to go to my next one. So I'm going to follow the spider. I'm going to click because I'm above. Then I'm going to click enter when I am below. And it's going to say, oh, you also have a 0 at 3 0. I'm going to do it for the third and final time. I'm going to go to 2. I'm going to move my spider closer to the 0. I'm going to be below it. Press enter. I'm going to crawl above it. Press enter. And it's going to tell me, oh, you also have a 0 at 5. But we already knew that from our table. But what if they were decimal values? Will I have known that from my table? No. So you got to be comfortable being able to navigate both. Okay. So now, do we have our factors? Yeah. So now I can write my factors. So my factors in this case would be, the 2 is still there, but we had x, and it's going to be -1, and x, -3, and x, -5. So this is it is fully factored. Okay. How this answers the question, it says, when does it happen? So it happens 1 when x equals 1, when x equals 3, and when x equals 5. So in terms of this problem, what date would that be? So x is the number of days past the 31st. So when is my first date that I would have 30,000 per insects? On the first day, that's a lot. What's one day after May 31st? June 1st, right? What's 3 days after May 31st?
June the 2nd, June the 3rd.
June the 3rd. Ignore that. What's 5 days?
June 5th. 4th.
5th. Okay, so they basically need to make sure they stay on top of their insect population every 2 days, right? You go out and put some pesticide, non-human harmful pesticide, and then come back. Okay, how do we feel about using the calculator to find our zeros and then writing the factors? Doable? Okay, all right, so this will be our stopping point. Tomorrow will be a classwork day, and then on Monday we'll take it to pick up talking about multiplicities. Okay, I don't care.